Each story has its start somewhere. Ismael's successful story starts in Saarbrücken. At the Institute for Experimental Physics of the University of Saarland, they are well versed in the smallest of worlds, in the world of nanocosm. Here, scientists analyze metals like nickel, iron or cobalt, and explore structures with a size of just a few thousandths of millimeters. They're on a quest for the correct combination of these materials in order to engineer a sensor which reacts extremely sensitively to magnetic fields. Basic research for Ismael. In numerous laboratory tests, the sensor proves that it can fulfill the scientists' expectations. They are now able to measure the magnitude of an external magnetic field with an accuracy sufficient to detect even the smallest changes, and also what's causing those changes. Certain objects, like steel parts or electric systems, interact with the Earth's magnetic field. So do aircraft taxiing at an airport. And it was for controlling this ground traffic that the magnetic detector was intended. The Ismael project enters the next phase. First trials under real-world conditions. They show that the scientific idea of the Ismael project works. The sensors measure exactly how the Earth's magnetic field is deformed by certain components of an aircraft taxiing over them, and how it straightens out after the aircraft has passed.
Ismael is a very good example of bringing fundamental research into practical applications. In the present case, we use magnetic sensors which have been developed during the past few years for practical applications on airports and especially for safety applications. This is a very representative example of fulfilling the whole value-added chain.
Here, where electronic components for the automobile industry are normally made, the detectors are now beginning to be produced. Airports are large. Many sensors are needed for monitoring the taxiways and parking positions. These sensors must work perfectly, not only in the laboratory, but also have to fulfill the strict requirements of an aviation designing works of a very special kind. Electronic specialists from St. Ingbert thus combine the magnetic sensor with electronic components, weatherproof it, and make sure that the current flows and magnetic fields are measured under all environmental conditions. So, within the framework of Project Ismael, the result of basic research in the university's laboratory is developed into a high-tech product, ensuring more safety at airports and able to withstand the harshest environments, thus finding new markets.
All over the world we have a lot of smaller airports. For all these airports who does not have the budget to install a ground radar, we will offer our sensor system which is able to fulfill the same applications as a ground radar. With our sensors we can detect the positions of all airplanes and other vehicles which are moving or parking at the ground. Compared with a radar system, we expect savings of 50% of cost. And because of that, there should be a market.
The Ismael project couldn't be imagined without the successful combination of science and economics, of basic research in a university's laboratory and product development in an industrial company. Above all, Ismael gives a very good example of how the European idea really works.
I think that's one of the most positive effects of the Ismael project, that we are not only doing research. The partners in the Ismael project are aiming to develop a new system, a new product which is going to be offered to airports all over the world. And I think this is a very good example how the European taxpayers' money is turned into new products, new services, which are of the benefit of the European citizen.
Place and forget. That's another great advantage of Ismael. Once installed beside an airport's taxiways or integrated into existing airfield lighting systems, there'll only be minimum costs for maintenance. The magnetic detectors are small in size, have no moving parts and consume extremely little energy. They'll now detect all vehicles solely by the distortion of the Earth's magnetic field they cause, an inexpensive and safe alternative for monitoring ground traffic at airports. Ismael has proven itself in practice. The magnetic sensor system tracks precisely the path of each aircraft on the ground. The plane's position is known exactly at all times. Furthermore, Ismael contributes to identifying every aircraft by analysing its specific magnetic fingerprint, be it a large passenger aircraft or a small Cessna, a jet plane or a similarly sized turboprop.
Frankfurt Airport, as one of the big European hubs, is equipped with the state-of-the-art surveillance technology. Nevertheless, Ismael, with his low-cost magnetic field sensors, can serve as an ideal add-on for these technologies we have already applied. And you don't have to forget that smaller airports can be equipped with a complete Ismael package, and so we have an affordable alternative to the existing radar technology.
Taxiing aircraft, buses, baggage carts or aircraft tugs, Ismael monitors an airport's entire ground traffic reliably, accurately and safely, unaffected by rain, snow or fog. The Ismael project, a milestone for safety in air traffic and a story of success for European research.